A rectangular channel has a width of 2 meters and carries a discharge of 5 meter cube per second with a depth of 1.70 meters. What will be the change in the water surface due to a hump of 10 centimeters height, 25 centimeters height, 50 centimeters height and 55 centimeters height? Calculate the minimum height of the hump that will cause critical flow. Neglect the energy losses. Now this problem is very similar to the previous two problems. So we will not get into details about all these calculations. We will directly plug in the value of the height of the hump and see what changes take place in the upstream downstream depth at section 2. Okay. Now height of the hump 10 centimeters equal to 0.10 meters. Okay, width, depth and discharge are already given in the problem. Now Froude number is 0.360. As it is less than 1, the flow is subcritical and the hump will therefore cause a drop in the elevation of the water surface. Now as the value of specific energy at section 2 is greater than minimum specific energy, which is the specific energy at critical depth. As the value of E2 is greater than EC, there will be no change in the upstream depth and we can continue with our calculations. Now we will use solver, data solver. Set objective section of this. Specific energy E2 at section 2 is 1.710. By changing the variable cell y2, okay, depth y2, okay, 1.583. Okay, so if the hump height is 10 centimeters, depth at section 2 will be 1.583 meters. Okay, and drop in water surface elevation will be equal to y1 minus y2 minus delta z, which is the height of the hump. So drop in water surface elevation will be equal to 0.017 meters. Okay. Now let us change the height of the hump. Now the height of the hump is 25 centimeters. Again, there will be no change in the upstream depth as the value of E2 is greater than value of EC. Okay, this is the specific energy diagram. Let us say this is the specific energy diagram for this rectangular channel which carries a discharge of 5 meter cube per second. Okay, so section 2. At section 2, the specific energy is 1.560, which is greater than specific energy at critical depth. Okay, so E2 is greater than EC, so there will be no change in the upstream depth, and we can continue with our calculations. The solver. Now, specific energy at section 2 is 1.560. By changing the value of y2. Okay, now is 1.397. It is 1.397. So if the height of the hump in this rectangular channel is 25 centimeters, the depth at the downstream depth will be 1.397 meters. Now let us change the value of the hump height. Now 50 centimeters equal to 0.5 meters. width of the channel depth, everything remains the same. Still, there will be no change in the upstream depth as the value of E2 is greater than EC. Okay, as you can see, the value of E2 is decreasing with increase in height of hump. Okay, this value is equal to E1 minus delta Z. Okay, it can be clearly seen that value of E1 is equal to E2 plus delta Z, right? So value of E2 will be equal to E1 minus delta Z. So as the value of the height of the hump increases, the value of E2 will decrease. Okay, because E2 is equal to E1 minus delta Z. So let us continue with our calculations. Okay, now specific energy at section 2 is 1.310, 0.975. Okay, now let us change the height of the hump to 55 centimeters, 0.55 meters. Now the upstream depth will change. Why? Because value of EC is greater than E2. Okay. So if minimum specific energy EC at section 2 is more than E2, what will happen? Upstream depth Y1 will change and E2 is equal to EC. Okay. And Y2 will be equal to YC, critical depth. So if the height of hump is 55 centimeters, depth at section 2 will be equal to critical depth. Okay, if you increase the height further, the depth at Y2 will remain minimum. Okay, and that will be equal to critical depth. But to make this flow possible, depth at section 1 will change. Okay, now let us calculate the new depth at section 1. Okay, if the height of the hump is 55 centimeters, what will be the height? What will be the depth at section 1? We will use, this is specific energy E2 will be equal to minimum specific energy at section 2. It is equal to 1.291. The new specific energy will be equal to 1.291 plus Y1. Okay. So E1 is equal to E2 plus delta Z. So E1 is 1.841. Now let us calculate the new depth. Now specific energy at we obtained these values using solver. Okay, all you need to do is open solver. Specific energy at uh, section 1 is 1.841. By changing the value of y1 dash. So we have obtained our answer. Okay, it is 1.735. Depth at section 1 will be 1.735 and depth at section 2 will be equal to the critical depth 0.86. It corresponds to minimum specific energy. If the height of the hump is 55 centimeters, then the upstream depth will change from 1.7 meters to 1.735 meters. And the downstream depth y2 will be equal to critical depth, which is 0.86 meters. What will be the minimum size of hump to cause critical flow? The minimum size will be 0.520 meters. How did we obtain it? Okay, it can be obtained very easily. This value is nothing but E1 minus EC. As the value of delta Z, which is the height of hump, okay, as this value increases, okay, our specific energy will go closer to this point C. Okay, at point C, specific energy will be minimum. Okay, E2 will become EC. So delta Z will be equal to E1 minus EC. So E1 is 1.810 and EC is 1.291. So we have obtained the minimum size of hump, which causes the flow to be critical over the hump.